Good afternoon, everybody. My name is Alan Reedy, and in today's presentation we're going to look at the topic of descriptive geometry, planes and lines. This is first introduced on the Junior Cert syllabus, and we're just taking the next step and just gradually introducing it into the Leaving Cert syllabus. I can't go into a presentation on geometry and lines without firstly just mentioning who was the founder of geometry, and we just have to thank a French mathematician by the name of Gaspard Monge. I hope I'm pronouncing that right, my French wouldn't be the best. So in the 18th century he was a mathematician, and he was actually developed the geometry. He was able to visualize graphically and demonstrate graphically the move from 2D objects to 3D objects, and from 3D objects back to 2D. And he was able to use these for military applications because he was in the army, and he actually led to a French reform of education after he finished his time in the army. And we'll talk about him a small bit later because I like to introduce one of his models that he used to actually promote his teaching of geometry, and it's still very relevant today and we can still use it in class today. Okay, so we'll just move on now. So the overview of the topic is plane, line, geometry. As I said, it was introduced in the Junior Cert cycle. We looked at lines, we looked at true shapes, true lengths, auxiliaries and cut surfaces. Okay, so we're just building on that now on this presentation. So how does this topic appeal to students in their three main learning domains? So the cognitive knowledge, the thinking, we'll be learning the theory through our textbooks, and we'll be trying to back up the theory with real life examples, either real life or in the classrooms. And then as effective attitudes, how do the students feel? Do they enjoy this topic? Do they struggle with it? Do they struggle to visualize some of the components when it comes to the planes and it comes to the different lines and different views? So we look at that and we'll ask them, would they prefer to graphically map it in 2Ds, or would we prefer to go and maybe look at a 3D software, maybe through SolidWorks, and see if can we make a model in that. And I think that's my preferred method for this module, because I think students, it appeals to them more being able to do it in that regard. They can just picture the planes easier. Okay. So how does this topic promote lifelong learning? I think this topic definitely develops, helps with the development of students' awareness and spatial abilities, and development of students' graphical and mathematical understanding. The thing about geometry is it crosses over towards mathematics syllabus. It crosses over to the construction, small bit of construction and a small bit of physics. So it is mapped across the whole Leaving Cert, and as I said, once they pass second level, whatever careers they choose to go into, they'll touch on it again in mathematics, engineering, construction. There'll be hints of geometry going through it. Okay? Now, the role of the teacher or the educator is to try and stimulate interest within the classroom and relate the topic back to everyday items. Okay? So as I said earlier, we're building on from the Junior Cert topic and the Junior Cert syllabus. So when I have a class from 5th years in, I'll try and relate back to them, and I'll say, before we go on to the talk, I'll say, can you picture this t-square? And to look at this t-square, could you tell me how do I get the true length of the t-square from that edge there? So it's the same thing, we rotate it up to looking at it at 90 degrees, or else you change your viewpoint that you rotate it up and looking at it at 90 degrees. And the same with the true shape of the t-square. So in order to see the true shape of the t-square, we rotate it up, or we look at it, we change our position to see it at 90 degrees. So we relate it back to previous knowledge, okay? And we just build on it. And we can see here the flagpole, it's the very same principle, okay? And we have the same views here. We have a diving board that represents a plane, the opening and closing of a door, the hinge point, another plane, and a laptop opening, okay? Now we take the next step on and relate back to solids that they can see. So here we have a pyramid, right? So before we introduce our oblique plane, we have our vertical and horizontal planes, okay? And then we introduce this oblique plane that's cutting a solid, okay? So we relate back to them, how do we do it in Junior Cert? You remember projecting a true shape. The solid is cut, we project at 90 degrees, and we form our auxiliary view and to form our true shape, okay? Now, as I mentioned previously, this topic is cross-curriculum. We'll hit it in maths. You can see here the heated angles and the the formulas for finding them. Small bit here in SolidWorks, it actually crosses over to construction and into geometry as well. Okay, and tiny bit in physics as well. We'll get into that later. So it is very beneficial, and it can be related back to multiple subjects in the Leaving Cert syllabus. Right? And as I said, part of the teaching is I like to relate it back to everyday items, and especially when we get into the deeper aspects of this topic, which will come to dihedral angles and planes being cut. So, and it confuses a lot of students, dihedral angles. So we relate it back to everyday items. There's a corridor. We have our two planes meeting horizontal, vertical, and our dihedral angle between it. And here we have just a diagram of a roof, a roofing diagram. There's a hip roof, and where the two slopes meet, two planes meet, we get our dihedral angle. Right? Now, another item available to us to teach is SolidWorks, and this wasn't available 15 years ago when I went to school, but in the past 10 years it's been really introduced and really focused on, and I feel that the use of this this program really helps students to kinesthetically grasp the topic better, because I can map it so much on 2D drafting on a board, on a page, but to really visualize, especially planes and geometry, I think it's beneficial to look at it in 3D and look in the computer and say, look, here's how it's done, and this is where the plane is rotated. So you'll see examples of this now. Here we are at the planes I was talking about. So it's just a basic shape of a triangle, and we have a plane, and we just inclined plane there and a vertical plane there. And in the next one we'll see, there we go. We have the vertical plane here, horizontal plane, and then we have the cutting plane, and we have a sphere in the middle here, and the cutting plane is cutting the sphere. So I would, demonstrating this to my students, I would say, what did you do in junior cert cycle? How did you remember when a sphere was cut, or a conic section was cut? It was cut, and how do we find the points? We divided our sphere or our cut surface into 30, 60 degree lines, 45s, whatever you're having, and then we just label the points and then take our measurements from the plan to project an elevation. Okay, so the assessment method is formative and sub-formative. If I'm teaching this module, I'll have classroom, mini classroom questions we handed out, and we'll complete them in class, or they might complete them for homework. And then when they come in the following day or the following week, we'll take out those questions, and I might get them to swap their papers, and they might correct each other's papers while we do a topic on the board. And then this will all be building up until a final year exam, end of year, Christmas exam, summer exam, or Leaving Cert exam itself. And here's just an example of an ordinary level question. So same thing again, same principle. We have a pyramid being cut by an oblique plane, and then we're projecting the cut surface of an auxiliary view. Okay, same thing again. The only difference, higher level question, very similar, but they'll always ask for a small bit more information, so we'll build on that. And here we have just this is the dihedral angle that they're looking for. So they just ask for, it's the same as the ordinary level question, just asking for a small bit more information, that's all. Okay, now further examples. This goes back to my point of our mathematician, our French mathematician. This is his example earlier on. This is what he used to promote and teach his geometric models. So he just it was a plain piece of card, and he put it at 90 degrees, and there was a steel rod then put through one piece of the card and brought to the other, and that represented the cutting plane. If you can see it there, that little rod represented the cutting plane. And this is an exercise that could be done in class. Absolutely, no problem. We could do that in class, so we could get the students to make up a piece of cardboard and to bend it over, and then label it as such, the different planes and the cutting section, and how the plane will cut the actual sections. And the other example is just a roof. They're just different roof members. So we have our two hip rafters, our crown, and we have our common rafter there, and that just shows the two different planes meeting at the end. Okay. No, sorry, that's just the end of my presentation. Would anyone have any questions on that?
You mentioned the first principles approach to learning. How does that relate to this topic?
So just when I was mentioning about the first principles approach, just about building on the students' understanding and trying to break down, when you're introducing a new topic, just to try and break it into simpler forms. What do they know already? how can they relate to this? So obviously I'll just bring in the example of the true length, the true shape. They've learned this from junior cert topics. So we're just building on that, introducing small new elements to that, such as the vertical plane, we have the oblique plane, and then gradually build it up, then we're able to answer a higher level question.
Okay. And in relation to the roofing model, could you explain what the dihedral angle is?
Sorry, actually I might just flick back the slides there, I might be able to just show just an example.
Yeah. The roof, is it? Yeah.
Yeah. Just the last one there.
Oh yeah.
There we go. Sorry. So when we were talking about roofing, here's our roofing model here. We have our two roofing sections, our two roof planes, they'll join, and here we represent is the hip rafter, okay? So when we talk about, and you ask why is that important? So the dihedral angle is a line where the hip will meet. So in construction terms, it'll mean your hip rafter will change. So its cut will change, and also if you have two planes at two different angles, so you have one plane here and this plane might be at a different gradient or a different angle, it'll also change the angle of your hip, the cut of your hip, and the backing bevel. That's what you'll be learning about. So the backing bevel and the hip will actually be planed, okay? So it'll fit nice and you'll be able to put your slates or your covering or whatever roof covering goes on it, okay? Perfect. Is that everything?
Yeah, thank you very much.
Okay, cheers, thank you very much for your time.